at y equal to 0 here on this surface at y equal to 0, the unit vector is minus ay, right? And at x equal to 0, the unit vector is minus ax. And on the other two surfaces will be the ax and ay. Okay? You can please the video to continue. So in this question, we need to find the surface current density inside the material. We call it volumetric current density, which can be found by curl M based on the given M. So we just take the curl of this M. So the curl of this M will be partial mz partial y, because we have only 4y. So it's only a function of y. So it will be 4 in, there's a mistake here, this should be x, 4 in x direction. If we take the curl of this M, which is directed along AZ, will be in x direction. Okay? And then we need to find the current on the surface. On each surface, so at x equal to 0, y equal to 0, x equal 0.3, y equal 0.2. We have 4 side faces. So in each face at x equal to 0, what should be the unit vector n? So we need to take m cross n. N here will be minus ax, because we take it outside the surface, outside the volume. And y equal to 0, the unit vector will be minus ay. Is it clear? This is x equal to 0. So at x equal to 0 on this surface, the unit vector will be minus ax on this surface. And on this surface, at x equal 0.3, the unit vector will be ax. And same for y equal to 0 and y equal 0.2. So by taking the m cross n on each surface, this will give you the surface current density. It will be 0 only at y equal to 0, because m is based on y. And it will be an opposite direction. So at x equal to 0, x equal 0.3, it will be same value but opposite direction. Now the last part is to find the total current Im on a bar face which is parallel to the y-axis at x equal 0.3. And we need to find the total current Im. It should be the current in ampere on this face. We need to find Im on this face. Okay. Y equal to 0 in y direction? Because y equal to 0, 4y will be 0. We have y here. M is equal to 4y. M is 4y. So when y equal to 0, y equal to 0 here. Everything is 0. Okay? Y equal to 0 here. This y is 0. Now we need to find the total current on the surface x equal to 0.3 on this surface. How can I find the total current? This surface. So I need to find the total current Im. It will be the integration of Gm, which as I already found in delta S. What is delta S on this surface? What's delta X on this surface? It's a vector. So delta S here will be what? dy dz in what direction? In x direction. So you will just use delta S in the integration and take the integration. So delta S will be dy dz in x direction, and you have Gm has been found by 4ax. So this will give you the total current on this surface. What about the limits of integration?
I just have one question about it, because the set value is from 0 to 1, because you're assuming that it's infinite, no?
I guess it has been mentioned here. Yes, it seems it didn't mention, but it should be mentioned the limits along the axis. So the limits along z here from 0 to 1, which is like 1 meter of the surface. Okay, it will be mentioned, should be mentioned the limits of delta z. and the limits of y is 0.2. So as if we are calculating the surface current on this surface here. So this is like 1 meter. Okay?
If we are assuming that it's infinite, what we should do with the
Because we need to find the current on specific surface.
No, I know. But let's say in another program, like we have an infinite bar.
Mm.
What should we do with these limits, for example?
To find the current in a specific surface, you need to define the limits. How can you find the current? How can you take the integration without having some limits? So you need to define the area where the current exists. Okay? It should be mentioned in the problem, but it seems it is not mentioned here, but it should be mentioned in the. It says per unit length. Per unit length means 1 meter. Okay? It says find the current per unit length. Unit length means per 1 meter along the axis. So we have like 1 meter length of the material. So the current will be 0.8 with the unit of, what should be the unit here? The unit of ampere. And we already defined the different material. So thank you. Can stop.